Greetings and welcome, friends. Today we're talking about multiplying matrices. How wonderful is that? Yesterday we talked about addition and subtraction of matrices, and we realized that in order to do that, they had to be the same size. And the size of the matrix was the rows, the number of rows the matrix had by the number of columns that the matrix had, right? And in order to add, we just added their corresponding elements. Now today, with multiplying, unfortunately, it's not going to be nearly as intuitive, alas. All right, where when I multiply matrices, there are going to be some size restrictions on the matrices, but not necessarily in the way that you'd think. They don't necessarily have to be the same size, although they could be. All right, and the process of multiplying will be interesting because it actually turns out we're not just going to multiply corresponding elements. All right, so it's not going to behave like some sort of distributive property. So here's my two matrices, 2, -1, 5, 1, and 0, 4, 3, 5, and I'm multiplying them. All right, so these are both square matrices, and what are their respective sizes? 2 by 2 is the first one, and 2 by 2 is the second one. Now the first thing I'm going to point out about matrices is that the inner numbers of their sizes must match. Okay? If they don't match, it's a no-go, and you cannot multiply them. You would just say, like if someone asked you to multiply them, you'd say no, and you'd run away really fast, like because you're not going to do that. It's not possible. So let's see. So that's the columns of the first matrix must match the rows of the second matrix. Now it turns out what they equal is going to be related to the outer numbers. All right, the 2 here and the 2 here are going to affect the size of my answer. All right, so my answer is going to be a 2 by 2 matrix in this case. Now it doesn't seem like that crazy when they happen to both be square matrices of the same size, but later on this is going to be a little bit more careful, where we've got to be a little bit more cautious about how this lines up. So the inner numbers must match, and then the rows of the first matrix will be the rows of my answer, and the columns of the second matrix will be the columns of the answer. Okay? So a little bit crazy so far. Now, in order to calculate this, all right, I'm expecting a 2 by 2 matrix. So I'm going to make a 2 by 2, so it's got 2 rows high here that I'm ready to work with. I'm going to give myself some room because I'm going to do some calculations here in a second, all right? So, but I'm expecting it to be 2 elements across as well, right? So in order to find the first row, first column answer, what we're going to do is multiply the first row by the first column, all right? And once again, I want to point out that it's row by column, all right? Row by column, which is convenient because it happens to be the same order that we measured the size of a matrix. It was rows then columns, right? And that's also how we multiply them, row by column, or roll call is the way I remember it. So for this, what I'm going to get is I multiply the row here by the column here, but I'm going to multiply the first number by the first number, and then the second number by the second number. All right? Hang on, it'll be all right once we get some practice on this. So let's see. So I'm going to have 2 times 0 and -1 times 3, and it turns out that I'm going to add my results. Okay, so that's where the first answer would come from. Craziness, I know. All right, so now for my next element, this is in the first row, second column. So what do you think I'm going to do? I'm going to multiply the first row by the second column. All right, so I'll have 2 times 4 plus -1 times 5. All right. And let's see, for the next one, I'm going to have, let's see, this is the second row first column element that I'm expecting here. So I'm going to multiply the second row, right, by the first column. So that's going to be, let's see, 5 times 0 plus 1 times 3, right? That's not that bad. So notice once again that it shifts as I go through those columns. And lastly, let's see if I can do this. This element is the second row, second column. And as you can probably suspect, I'm going to multiply the second row by the second column. So that'll be 5 times 4 plus 1 times 5. So let's simplify this. So this is what this is equal to. So this equals, let's see, once again it's going to be 2 by 2. I'm going to show a little bit more work just for starters here. 2 times 0 is 0 minus 3. Let's see, 2 times 4 is 8 minus 5. 5 times 0 is 0 plus 3. And this one is 20 plus 5. All right, so we'll show a little bit more work than we need just for our notes, so that way we know what we're doing when we're on our homework. So this whole first part, I would let you skip this whole first part and let you do all of that mentally and just do 2 times 0, and I would have had you write down 0 rather than this whole part. You know what I'm saying? Yeah, it'll save us some time. So let's see. So this is going to equal the 2 by 2 matrix. 0 minus 3 is negative 3, and then positive 3, positive 3, and 25. And that will be our answer to the product. All right, now this, I'm sure, feels really abstract, and you'd be like, why on earth would this be helpful? But it turns out that multiplying matrices is going to be a very powerful technique for solving systems of multiple dimensions later. All right, so this is actually going to be probably our most powerful technique for solving systems. All right, and there's other stuff that you can do with it as well. So that's how we multiply matrices for starters. Now, one of the things I want to point out, or let me ask you this question. All right, if this was matrix A times matrix B, do you think that would be the same answer I would get if I do B times A? So if I do matrix B times A. Let's actually write this out. We won't necessarily go the whole way, just until we feel confident in our conclusion. So let's see, if I have 0, 4, 3, 5, and I'm multiplying by 2, negative 1, 5, 1, do you think that's going to be the same thing? Now, our instinct, right, we might think about plain old numbers, that addition was commutative, we could do it in any order, and multiplication is commutative with plain numbers, and that can be done in any order. So the question I'm asking here that we're trying to get down to the root of is matrix multiplication, all right, specifically of square matrices, is that going to be commutative? Let's see. Well, let's see what happens. So let's see, first row, first column, first row, first column. Oop. 0 times 2 is 0, 4 times 5 is 20. Uh-oh. Let's see, first row, second column would be first row, second column. So that's going to be 0 plus 4. Let's see, second row, first column, 3 times 2 is 6, 5 times 5 is 25, and yeah, I think it's kind of becoming clear that this isn't going to work, and this is negative 3 plus 5. And we end up getting equals 24, 31, and 2, which is nowhere close to that other matrix. All right, so that's something we'll want to note, is that matrix multiplication is not commutative. It can be done in any order. And you might have suspected that for non-square matrices.
What?
What?
Any what? Any work, do you say?
Commutative. What was your question? I'm sorry.
What is commutative?
Commutative means it can be done in any order. Commutative means this: A times B equals B times A. All right, and that is not true for matrices. All right, And that might have made sense for non-square matrices, right? If I have a 3 by 2 multiplied by a 2 by 4, when I switch the order, the inner numbers wouldn't match for the dimensions all the time, so it doesn't necessarily work out. And sometimes, even if I could switch the order that I multiply them, I might end up with completely different sized matrices, never mind the right size and the wrong numbers. So that's an important point to note. And actually, another thing we'll discover about matrices later is, I mean, we're working with multiplication now, and you might notice that today's lesson's title does not include division. And it turns out there's no such thing as matrix division, although we will eventually talk about a technique to accomplish the equivalent of that.
Not today.
But not today, so don't you worry. All right, let's try this example. Multiply. And the first thing we'll do is figure out the sizes of these matrices. I'll let you write these down as well. So what size is this first matrix? Rows by column.
1 by 3.
1 by 3. And I'm multiplying that by, what's the size of the second matrix? 3 by 2. So first question, do the inner numbers match? Yep, the inner numbers match. So that means I can multiply this. And the size of my answer matrix is going to be what? 1 by 2. And that's really weird the first time you see that. It's like, how on earth is this going to happen, right? This is kind of crazy. Well, let's see what we get here. So I'm expecting a 1 by 2, so I don't think it's going to be very high. And I'm going to have 2 elements here, right? Sort of thing like that. Hopefully I can fit it here. So let's see. For my first row, first column element, right? 1, 1 there. I'm going to multiply the first row, the only row, by the first column. So in doing that, I'm going to have 1 times negative 1, all right, which is negative 1, plus 2 times 2 is 4, plus the 3 times 3 is 9. All right, so notice that as I multiplied this row by column, I shifted this times this, and then this times this, and then this times that. Okay, so this was shifting this way, and this was shifting that way as I was doing those consecutive products there that I was doing. All right, so let's see if we can get this first row, second column answer. And I'm multiplying the first row by the second column. So that's going to be 1 times 1 is 1, plus the 2 times 4 now is 8, plus the 3 times the negative 2 is negative 6. So this is equal to, see, negative 1 plus 4 is 3, plus 9 is 12, and 1 plus 8 is 9, minus 6 is 3. And this is going to be my answer. And once again, I want to point out that there's no commas in between the elements of matrices. I know that's kind of weird. But so when you're doing your work, just try to keep a little bit of a space in between your stuff so you hopefully don't get as confused.
If you put commas, is it wrong?
Yeah-ish. Just don't use commas for this.
Why we can't? Like, I feel like that'd be more clear.
I agree. Yeah, I agree. It would be more helpful. Well, it's just it's probably because maybe you could view it as a favor. Think about if I had you enter commas between everything, and I had a 3 by 3 matrix. It's a bunch of commas that you have to do. That'd be 6 commas. Maybe mathematicians are just trying to be lazy and save themselves a little bit of time. They don't want to have to write everything out all over. That's probably what they're doing. But I agree. It could result in some errors in calculation. So let's do our last example. All right. So let's see. Let's look at this. I've got what size is this matrix here on the left? 2 by 4, and I'm multiplying by a 4 by 1. So is that able to be multiplied?
Yeah.
Yep, because the inner numbers match. And my answer matrix I'm expecting to be a 2 by 1. Remember, that's rows by columns, rows by columns. Question, could I multiply these matrices in the other order? No, right? If I took this guy and moved it over here, the inner numbers would have been 1 and 2, and it wouldn't be possible. So I do want to point out, you have to multiply matrices in the specific order they're given to us. So let's see. I'm expecting a 2 by 1, so I'm going to give myself room for 2 columns. And I'm expecting actually only 1 element width, but it might be a little bit of room for the work here. So I'll give myself some room to work with. So let's see. To find my first row, first column answer, I'm going to multiply the first row by the first column. So that's 10 times 1 is 10, plus 13 times 0 is 0, plus 3 times negative 1 is negative 3, plus 13 times 1 is 13.
Can you circle what's over here?
I've multiplied the first row by the first column because I was calculating the first row, first column answer. Right? So let's see, let's try second row, first column is going to give me the second row, right? First column answer. So let's see, 4 times 1 is 4, 16 times 0 is 0, 10 times negative 1 is plus negative 10 or minus 10 if I wanted to write it that way, and 21 times 1 is plus 21. Now even though this seems very wide, how many elements wide is this? Just 1 width. So I'm expecting it to just be a little 2 by 1 matrix when I'm all said and done. Let's see, 10 plus 0 is 10, minus 3 is 7, plus 13 is 20. And 4 minus 10 is negative 6, plus 21. What's that, 15? And I'm done. Right? So yeah, it takes a little practice to get used to the rows by columns thing. You're just multiplying those elements and you're shifting to the right for the row and down on the column for each one, and then you add them all together. So we're going to have plenty of time for practice today, which is very good news for us. So let's do that. Thanks for watching, Internet friends. Bye-bye.